Today we learn more exciting concept about the line equation in the form of slope and intercept. In this equation, why we call m as a slope of the line? In your 10th standard, you will be seeing in the pair of linear equations certain conditions to satisfy whether the lines are parallel or intersect or coincident. Why this is true? For all these questions, you will get clarified in this video. Let's start. First, we will talk about the slope and angle. If we see the three scenarios here, there is the ground here, and over that we have the wall, and there is a ladder is placed to climb the wall. Okay, so we have placed the ladder in the three different places. In the first case, we place the ladder not much steeper way, right? But in the second case, it is coming closer to the wall. That's why if you are looking at the slope is much steeper, we will say, right? And the third case is much more steeper than other two cases and is coming much closer to the wall. Okay. So what do you observe here, right? When the angle between this ground and this ladder. So let's take this a theta angle between ground and ladder. So if this theta angle is keep increasing, okay, it's coming closer to the wall, this theta angle is keep increasing. That means the slope is become much steeper. That means it's a dangerous steep, right? Let's take a hill. Okay, this is the hill. Let's take the hill. Okay, so if the slope is very less here, okay, you can easily climb the even mountain or hill. Okay, but if any hill is there like sharp way like this, it's very difficult to climb for yourself. Okay, you will say that it's much steeper. Okay, and that means the angle is high. Okay, the angle between the ground and the angle between the ground and the mountain is high over here. Okay, but if you check this case, the angle between the ground and the hill is small. Okay, so that means it is a less steeper. You understand, right? If you define this as a line, when you look at it from the side, this looks like a line, right? And this is having some angle between ground and this line, right? So this angle we are calling the angle for the line. Okay, this is always measured the positive angle from the ground like this. Okay, so in this scenario, this angle is maybe around 45 degrees, and this angle, if you see, it is 60 degrees, and this angle probably like 75 degrees. Okay, so angle line will be measured from the ground to the line. Okay, so then what about the slope then? How do we see the slope? Okay, slope we will be defining like the change in the y. Okay, so see here clearly, change in y to change in x. So what is y, what is x? Let's take this ground. Okay, this ground is an x-axis. In the coordinate system we will take, right, this. Let's take this coordinate system. This is x-axis and this is y-axis. Okay, so if we check this, all the three scenarios, we are keeping the same height, right? For example, the height is something like y1. Okay, in all the scenarios we have the same height of the wall. Okay, y1. Let's take. But if we take the x distance between the wall and this one, right, we are keep changing. Okay, this will become x1 to here like x2, and here like x3. We are keep changing. So they define the slope, right? How much steeper, how much y is changing with respect to the x. Okay, for example, the height is y1 here divided by x1. It will give, right, it will give some ratio. So whenever the x is smaller, this ratio will become the higher. So whenever the x is smaller, this ratio will become higher. That means it's having the higher slope. That means steeper slope. You can call it like that, right? It is a steeper slope. And when x is higher, it has a very slant way, and the lower the slope or the lower the angle, right? That way we are defining the slope of the line. This is the ground and this is the hill. When you climb the hill along, when you are climbing the hill from the point, this point to this point, So you are traveling vertically some distance and horizontally some distance, right? So if you take the two components of your traveling, you are traveling something like dy, okay? Let's take in vertical transfer is the dy. So you are changing from point here to point here. So you travel vertically here, and you have traveled delta x is the along the, so this slope is defined like delta y by delta x. So that's where they define the line equation slope. So you know the trigonometry, right? If you take this the right angle triangle here in this way, if you take the right angle triangle, how do you define the tan theta here? How do you define tan theta? Tan theta equal to, it is opposite side by adjacent side, right? Here opposite side, if you take here, right, y1 by, this is x1, right? So here with this you can find the angle of the line. But this y1 by x1 we are calling the slope of the line. Simple, right? So it's almost equal to tan theta we are calling like slope of the line, and theta we are calling the angle of the line. Clear, right? Let's see general form of the line equation. That is ax plus by plus c equal to 0, right? So I am rewriting this line equation into another form. Let's keep this by into this side. Let's take this by and send all other terms to the other side of the equation. So it becomes like minus ax and minus c, right? So let's keep the y along this side, okay? So sending to the b to other side. So this will become like minus a by b x plus minus c by b, right? Now I will take it this term is another constant like m, and this one I will take another constant like c. This is not c, it's another c, capital C. Let's take this is a small c. Okay, I'm just telling. So because the general form they write is always like write y is equal to mx plus c. So that's the reason I want to keep this c here. Okay. So then this equation will become like y is equal to mx plus c. Here we have the question. Okay. So here m they are calling slope of the line, and c is here intercept. So why this is called slope of the line and why this is called intercept? Let's see. Let's take a coordinate system. So this is the x-axis and this is the y-axis. This is our line. So we have written the line equation in the form of y is equal to mx plus c line. Okay. So let's take 2 points along the line. I'm just marking two points here. So this is the point A and this is the point B. So let's take this point A is x1 and y1, and this point B is x2, y2. What I said, when I travel from the point A to point B, any person along this line, so how much change in the y divided by how much change in the x we are calling the slope of the line, right? So let's draw a few construction lines. Yes, I have drawn one line parallel to the x and one line is parallel to the y, and the intersecting point I am marking like C point. Okay. Now it formed the right angle triangle here, right? So what we are calling we are calling the slope. We are calling the slope BC by AC, right? So how much change happened along the y direction compared to the x? So this we are calling the slope. Okay, so this is BC by AC, right? P point is located y2 distance from the x-axis. This point is, what is the meaning of this point? So meaning of the point is the viewpoint is located y2 distance from the x-axis and x2 distance from the y-axis, right? So this will become like y2, and what about this point? This will become like y1, right? So then BC will become like y2 minus y1. AC distance will become like, this is x2 and this is x1. So this will become like x2 minus x1. Now, if you know the 2 points in the line, the slope can be defined like BC by AC, right? So this will be the same everywhere in the line. It will be C, it is y2 minus y1 by x2 minus x1. So this is the slope of the line, right? Then what about the angle of the line? Let's take this is the theta, I said, right? From the positive. So let's take tan theta equal to, if you know the 2 points, y2 minus y1 by x2 minus x1. Now you are clear about angle of the line and slope of the line, right? So tan theta is slope of the line and theta is the angle of the line. That why we are calling like m here as a slope of the line? In the form of y is equal to mx plus c, m we are calling like slope of the line, right? Then why we are calling m is slope of the line? So let's see why you call. So the form of the line equation y is equal to mx plus c, right? Okay. Now let's take, there's a 2 points x1 comma y1 and x2 comma y2 is passing through this line. Okay, then what does it mean? It satisfies this line equation, right? So let's substitute the first point into this equation. So it became like y1 is equal to m into x1 plus c, right? Second point also will satisfy this line, right? So if we substitute this point into this line, it will become like y2 equal to m into x2 plus c. So we have the two equations now here. And from these two equations, we will find the m and c. Okay. Just subtract equation 2 minus 1. Okay, 1 minus 2, 2 minus 1 does not change any difference. Let's do that way. 2 minus 1. So y2 minus y1 from the left side equal to the right side mx2 minus mx1, and the right side c minus c is become the 0, right? So if we take common here m, it will become like x2 minus x1. So then what is the m here? y2 minus y1 by x2 minus x1. If you recollect in the previous slide, we defined, right, the slope of the equation is y2 minus y1 by x2 minus x1. That means the change in the y by change in the x, right? If you know the 2 points. So this term we are getting directly as a like m right here. So if you are written the line equation in the form of y is equal to mx plus c, directly m we can take it as the slope of the line. Directly you can take, and if you equal to tan theta equal to the m, then you will get the angle of the line. So this is the reason we are calling m as the slope of the line. So when you equate the tan theta equal to m, then you will get the angle of the line. What is the meaning of intercept? Let's take general form of the line equation, that is y is equal to mx plus c. Okay, let's take this is the line. The equation is y is equal to mx plus c. Okay. So m already we have seen, this is the slope of the line. So we will see, okay, this is let's take the coordinate axis, this is x-axis, and this y-axis, this is negative x, and this negative y. Okay, so this is the line equation in this. So what happens when x is equal to 0? Let's see. So this is the line equation. So when x is equal to 0, what happened to this above equation? It will become like y equal to c. See, what are the value of the y is becoming c. Okay, so yeah, so if you take any point in this line, right? So for every point on the line, right, it has the corresponding x value and y value, right? When x values become the 0, what are the y values there, right? That is equivalent to this constant like c. That's the reason whenever x is 0, whatever the line intersect at the y-axis, right? That distance we are calling intercept to the y. When this line is passing through the origin of the axis, like 0, 0, let's take this out. That means x is equal to 0 and y is equal to 0. If you substitute these two into the above equation, what will happen? It becomes like 0 equal to m into 0 plus c. So this intercept will become 0, right? For example, so line is drawn at line is drawn, this line is drawn at any place. If you know slope of the equation m and this intercept at x is equal to 0, so what is the distance of the intercept? Then we can find the line equation, right? So the two constant only we do not know in the line equation. So for each line having the different slope and different intercept. I have drawn a line equation. This line is passing through the origin of the coordinate system, so 0, 0. So I have not given any intercept here. I just taken the line equation. Y is equal to tan 45x. Here 45 is the angle of the line. Tan 45 will get the slope of the line, that is m. So I just written the line equation in the form of y is equal to mx here. Where I'm keep changing the angle here from the 0 to 9. And I'm not giving any intercept 0 here. So how the line is changing, you just see here. See, this an angle is changing, the line equation is changing, is corresponding to that, right? So these are the different lines with different slopes. Now I will add some intercept to this. Okay, for example, this line I'm just shifting to the top and bottom like that, right? So I'll give the intercept as some 4. See, then directly this line is moving to the, when added with some intercept 4 here, the directly this at x is equal to 0 and the y will become directly 4 here. So this 4 we are calling intercept here. So the angle of the line I'm just keeping the same. For example, I'm just keeping the angle of the line is 45 degrees here. So that intercept will not change. So that intercept point only, this line will be keep rotating to the different angles. Because it's when x is equal to 0, y is 4 here. So I'm just changing the intercept here. Then how the line will move, you see. It just move the parallel to the original line. So it won't change the any angle here. See, it's just moving the parallel to it. So it's not changing its angle here, like 45 degrees maintaining, but intercept is changing to different numbers. I'm just varying this intercept from the 0 to 10 here. So as soon as touch the 0, again it start move up because I just given 0 to 10 here. So this intercept is keep changing, you see, but it's maintaining the line angle is same. So now we were clear about the angle of the line, slope of the line, and intercept, right? Two pair of linear equations, the form of a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. We know these conditions, right? So we will prove now why it is true, okay? So I'm rewriting this form into y is equal to mx plus c form, okay? If you take general form of the line equation ax plus by plus c equal to 0. So this equation we have written in the y is equal to mx plus c format. So we are keeping by term this side and sending other two terms to other side. And we divide with b here, it become like minus a by b x plus minus c by b. Y is equal to mx plus c. This is another constant. Okay. So this is the capital C. Okay. When can you say the two lines are coincident or parallel? So if you take the coordinate system here, x and y, if the two lines are having the same slope, that means it's not changing its angle. So this is the angle, right? So when two lines are parallel, when the angle is not changing, then we are calling like parallel or coincidence. When it's coincidence, the slope must be equal to the line 1 to line 2, right? That means both lines having the same slope, right? Okay. So if you take this line equation in the form of y is equal to mx plus c in the two different lines, that is became like y is equal to, first line become y is equal to m1x plus c1, and the second line equation is y is equal to m2x plus 2. If these two lines are parallel or coincidence, means the first condition must satisfy m1 equal to m2. That means both lines having the same angle or same slope, right? So what is the m1, m2 here? If you see here, m1 is minus a by b, right? So if you take in this form of the equation, so if we substitute here, the first equation, it will become like minus a1 by b1. And similarly, for the second equation, it will become like minus a2 by b2. If you rearrange this one with the negative sign cancelled it, and we get like a1 by a2, a2 is coming here, okay, equal to b1 by b2. So if any two line equations in this format, if a1 by a2 equal to b1 by b2, then these two lines are either parallel or coincident. When we are calling the coincident here, when the C1 equal to C2, okay, then this will become like coincident. When C1 is not equal to C2 and just only the angle is same, then that lines are parallel, right? So what happens C1 by C2 if you make equal to these terms, like, right? This is a capital C, right? So if you make it to the here, minus C1 by B1 equal to minus C2 by B2, right? If you make negative signs cancel here, and if you rearrange B1 this side and C2 this side, so it became like C1 by C2 equal to B1 by B2, okay? So that means B1 by B2 is here, right? That equal to C1 by C2, okay? So if it become like C1 by C2, then the two lines are coincident. Whenever C1 and C2, this intercept also becomes same. So that's the reason the condition for the coincident is m1 equal to m2, that is corresponding a1 by a2 equal to b1 by b2, and it has the same intercept like c1 equal to c2, that's corresponding equal to c1 by c2 here. So that's what we are calling the coincident. Parallel means, so that angle should be same, that's why a1 equal to a1 by a2 equal to b1 by b2, but it should not be equal to the same intercept. Parallel means it has the different intercept. That's why it should have the same angle. That's the reason it should be parallel, and it has the different intercept here. I think we need not to prove this one. Okay, when slopes are not same, that means these two terms are not equal, right? So when m1 is not equal to m2, okay, any lines when slopes are not equal, that lines must intersect at any one point, because it's one line. If you slightly change the angle, so another line that intersect at the single point. So we need not to prove this first one, okay? Whenever the slopes are not equal, that line will definitely intersect at single point. I hope you understand the concept of the line and proof of this pair of the equation, coincident, parallel, and intersecting. Please support the channel by subscribing it.